Bismillahirrahmanirrahim. Dear students, in the last lecture, the restricted list was described and the stack data structure along with its type and its applications being explored in detail. The second data structure, the queue in the restricted list, will be discussed in today's lecture. Ladies and gentlemen, queue is a linear data structure that allows insertion of the element at the rear end of a queue. It also permits deletion of the element from the front end of the queue. The queue exhibits the philosophy of first in, first out, or FIFO. The queue is also described as an abstract data type because it is specified in terms of operations and it encapsulates or keeps the data and all operations on that data to be localized in one section of the program. Dear listeners, the reason behind the deployment of the queue is the philosophy that the queue maintains the order in which elements enter a queue is the order in which they leave. This is called first in, first out ordering, or simply FIFO strategy. The queue can be implemented through an array in case of static queue, which is fixed in size and requires the maintenance of the two pointer variables, namely the front and the rear, containing the location of front and rear ends of the queue respectively. Whenever the insertion function is invoked, the rear is incremented once. Every time the delete function is called, the front is also incremented once. Dear viewers, this slide depicts the static queue represented by an array. As you can see in this slide that the front indicates the first location, whereas the rear indicates the fourth location of the queue represented as an array. Dear students, the delete update operation is sketched in this slide, maintaining the front pointer accordingly. As you can view that the front is incremented to the position number 2 of the queue in an n size array after invoking the queue delete operation. Ladies and gentlemen, this next slide portrays the update operation of insertion, which maintains the rear pointer accordingly. As you can observe that when the new element EE has to be inserted on the fifth location, the rear is first incremented to point to that location of the queue in an n-size array. Dear students, mentioned in this slide is the queue insert algorithm that calls the queue insert procedure containing the parameters like the name of the static queue, as in this case it is queue, the size n of the queue, the front and rear ends of the queue to maintain these pointers, the item to hold the element to be inserted on the queue. Whenever the queue insert procedure is called, it also checks the overflow conditions of the queue. Dear viewers, this slide describes the queue delete algorithm, which is invoked by queue delete procedure call that contains as its parameters the name of the queue, the total size n of the queue, the front and rear pointers to maintain the locations of the queue, and the item to be deleted from the queue. Dear students, next comes the dynamic queue implemented using linked list. It is variable in size and its size depends upon the memory available. The dynamic queue contains many nodes consisting of info fields holding the elements and link fields to hold pointers to the neighboring elements. The dynamic queue requires the maintenance of the two pointer variables, the front and the rear, containing the location of front and rear ends of the nodes of the queue respectively. Dear viewers, the linked list representation of the dynamic queue is depicted in this slide, where the front points to the contents AAA in the linked list node and the rear points to the contents DD of the linked list node that has null value in its link field, indicating the general or simple queue structure. Ladies and gentlemen, the insert operation on the dynamic queue is sketched in this slide, describing the effects on the rear pointer before and after the queue insert procedure call. Dear viewers, the queue delete procedure is indicated in this slide, explaining the impact of queue delete procedure invocation on the front pointer of the dynamic queue. Dear students, the queue can be found in different types, from the general queue or simple queue to the circular queue. Then comes the double-ended queue, and finally the priority queue. Ladies and gentlemen, the linear queue, also called the simple queue or the general queue, can be implemented through linked list. It is variable in size and has no limit on the capacity. It dispenses with the need to maintain expensive data movement and to check the overflow every time in case of insert operation. Dear students, the linear queue has an issue that it will not allow any insertion when its rear end indicating the maximum size being occupied, even though its front pointer specifying that some free space is existed after deletion operation. To overcome this issue, the circular queue is designed for efficient management of space, on contrary to the linear queue. The circular queue is implemented normally through the array and it is fixed in size. The circular queue requires recurrent maintenance of the front and rear pointers in case if the rear points to the maximum size and front does not hold the first location address. Then the rear must be reset to the first location to insert a new element exhibiting circular characteristic. In another case, if the front is pointing to the maximum size of the queue and the delete operation is invoked, then the front will be assigned the first location if there exists an element at this location. This again exhibits the circular characteristic. Dear students, the circular queue can be deployed by an operating system in the round-robin algorithm to schedule the processes in the uniprocessor environment. This example indicates such a case where the queue is initially empty and it is further occupied as and when the processes arrived. The queue maintains the pointers in circular fashion, and finally the space is freed up by all the processes. Ladies and gentlemen, the double-ended queue with the acronym Deque is implemented through circular array. It contains pointers left and right to point two ends of the Deque. The elements can be inserted or deleted at either end, but not in the middle of the Deque. The elements can be extended from the left end to the right end in the array implementation of the double-ended queue. If left points to the null value, this means that the Deque is empty. Ladies and gentlemen, the double-ended queue also requires the maintenance of the two pointer variables and checking of the overflow and underflow conditions accordingly. It comes in two variations. The first variation is input restricted Deque, which allows insertion at only one end of the list but permits deletion at both ends of the list. The second is output restricted Deque, which permits deletion at only one end of the list but allows insertion at both ends of the list. Dear viewers, this slide depicts the Deque pointers and their positions after being maintained in both cases. Dear listeners, finally the priority queue is defined, in which each element has been assigned a priority. An element of higher priority is processed before any element of lower priority. Two elements with the same priority are processed according to the order first come, first serve, that is, the order in which they were placed in the queue. Dear listeners, the priority queue may be maintained in various ways in the memory, either by one-way linked list or by the two-dimensional array or through the heap. For instance, the priority queue may be applied in time-sharing systems to process higher priority programs first, and programs with same priority form the standard queue procedure. Dear students, for further details and studies, you are hereby advised to consult the 6th chapter of the data structure by Lipschutz. Till the next lecture, stay home, stay blessed, keep learning.